Assalamualaikum, my name is Amirul Akmal bin Zuhaili and my matrix number is DE190203. So I'm a student from Power Engineering Lab 3, Section 2 and Group A2.2. My group stand of 3 persons, which is me, Akif Rushadi bin Azim and also Amirul Ali bin Syahriman. The title for our experiment is AC 3-phase 2-pole synchronous motor. So basically we will have 3 activities, which is activity 6, activity 7 and also activity 8. So without further ado, let's go to activity 6 first. Alright, activity 6 is about star connection. Here we can see a table. So the table 5.1 shows the data collection which has been taken at the stator. So we observe 5 parameters, which is speed, voltage, current, power and also power factor. For load, we make it as an input which we vary the value from 0 to 0.8. So if we look at the voltage reading here, we will notice that when we increase the load to a certain amount, the value of the voltage for red phase, yellow phase and blue phase, it will change, and sometimes it can increase and sometimes it can decrease, but the changes is just at a very small amount. Alright, so we can see here 145.8 and then 146, 145.7, right? A very it's just a slight difference. And then if you see at the 3 phase here for the voltage, the value is approximately the same, which is it between 249 and 248. Okay, so unlike voltage, the current reading, it will increase when the load is increased. Right, so here we can observe that the value of the ampere is 0.44 and then it increased to 0.45 to 0.48 to 0.55. Right, and it is not for red phase, but it also occur at the yellow phase and also the blue phase. And then if you look at the 3 phase, we will increase from 0.32 to 0.83. Right, so same thing happened to the power. Right, at the voltage, we can see that for red phase, yellow phase and blue phase, if we increase the value of the load, the reading for the power, it will increase as well. Right, which we can see at the 3 phase. For the power, the value is increased from 110.6 to 313. And then for the power factor, if we look at the red phase, it increased. The value of the power factor increased when we increase the load, right? But if we look at the 3 phase here, we can see that first it decreased, and then it will increase, right? So at here, which is we know that the power factor, the value of the power factor, it is a bit unbalanced because sometimes it decrease and increase at a very high, like the difference between the 0.77 to 0.75 is huge. Alright, if you compare with the voltage, which is it only slight difference between the first value and the second value, right? And then for the speed here, we can see that the increasing in load, it doesn't affect the speed, the value of the speed. Alright, so it remain unchanged, which is at 3000 rpm. Right, so last but not least, here at 0.8, for the load at 0.8, we didn't insert at the value. Alright, because when we set the value to 0.8, the motor, it start to unbalance. Right, which means it reach its stall condition. Right, and at that moment we need to stop the motor from operate by turning it off. Right, next is table 5.2, which is the data collection at the armature. So the input is still the same, which is the load. So we vary from 0 to 0.7. 0.8 is not here because we know it is where the motor has reached stall condition. So the measured DC voltage is 13 volt for each of the load, and then the measured DC current, it change at the different load, which is we can see here 2.45 ampere, and when the load is 0.1, it is 2.57 ampere. Right, but what we can observe here is it is only a little changes happen at the DC current. So beside it is the table 5.3, which is the calculated horsepower. So the 3 phase horsepower, we can calculate it by using the formula of power divided by 746 watt, because we know that 1 horsepower is equal to 746 watt. So here in the table, we can see that when the load increase, the 3 phase horsepower will also increase. Okay, this is because we know that it is related to the power, and the power in the previous table, which is table 5.1, it increased when the load increased, so that's why the horsepower will increase as well, right? So that's all for activity 6.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Arfishal Devi Azim, and my matching number is DE10184. And in this part of this video, I'll be talking about the data collected for the 3-phase synchronous motor in delta connection. So right here we have table 5.4, which is the data collected for the stator part of our motor. So right here we have our load. This is our speed of the motor. This is our AC voltage, AC current, our power, and our power factor. So let's start. As you can see, for our speed of the motor throughout the experiment from 0 to 0.7 Newton meter, our speed is remaining constant at 3000 RPM. This is because of the motor maintaining its synchronous speed. At 0.8 Newton meter here, there is no speed. This is due the motor being stalled. So let's move on to the AC voltage. As you can see here, the AC voltage for each phase here is almost the same. This is due because this is a delta connection, so each phase have the same voltage level. So for the AC current here, we can see that throughout the experiment, when the load increased, the current also increasing. This is due to maintaining the 3000 RPM. Because of the load increase, the power intake for the motor also increases. The voltage remain the same, but the current increases to increase the power. So that's why the power and the current increases throughout the experiment. And this is the power factor, and the power factor is almost increasing as well, but it's increasing slowly. So let's move on to the next table. So this is the armature data collection for delta connection. So what we have here is the our load. This is our DC voltage and this is our DC current. And DC voltage and DC current is supplied to our rotor. So we have the load from 0 to 0.8. We can see that from our load to 0 to 0.7 Newton meter, we can see that our DC voltage and our DC current are almost similar. For DC voltage, it is 13.3 volt, and our DC current is around 2.5 volt. I mean 2.5 ampere. But at 0.8 Newton meter here, we can see that our DC voltage increased to 16.6, and our DC current increased to 3.31 ampere. This is due when the load is 0.8 Newton meter. Our 3-phase is synchronous motor is stalling. So meaning that our motor only can handle load below 0.8 Newton meter. After that, the motor will start to stall. So let's move on to our horsepower. Here we have our load from 0 to 0.8 Newton meter, and this is our horsepower. How we calculated the horsepower is from our previous table, which is from table 5.4. We take the 3-phase power and divide it by 746, because 1 horsepower is equivalent to 746 watt. So this is what we get from the calculation. We get that when the load increase to 0.7 Newton meter, we can see that our horsepower increased to 0.414 horsepower, meaning that the 3-phase synchronous motor power intake is increasing because it want to maintain the synchronous speed, which is 3000 RPM when load is increasing. But we can see that at 0.8 Newton meter here, our horsepower is decreasing to 0.299. This is because our 3-phase synchronous motor is stalling at 0.8 Newton meter load. So this shows that our 3-phase AC synchronous motor, like I said before, only can handle load below 0.8 Newton meter. So that's all for the delta connection, data collection. Thank you.
Now we proceed with activity 8. So this is figure 5.7, which is the equipment arrangement layout for the star connection. So in the middle, we can see there is motor assembly panel, which consists of carbon brush, rotor, stator, coil, and also the motor drive. So the component that need to use along in order to complete this experiment is supply. We have two type of supply, which is one is DC supply and another one is the three-phase supply. So the measurement unit that connect at the DC supply is analog meter and also the multimeter, while for the three-phase supply we use the digital power meter to get or to measure the value of these four parameters, which is the voltage, current, power and also the power factor. So the DC supply, we connect it to the carbon brush. We just simply straight connect it to the carbon brush, and then on the another side we can see the negative terminal, so we connect it back to the negative terminal of the DC supply. So for the current measurement unit, we need to connect it in series, while the voltage measurement unit, we need to connect it in parallel. So for this part, we need to use three-phase supply. So we can see red phase, yellow phase, blue phase and also one neutral. So these four wires, we need to connect it to the first digital power meter until the last digital power meter, and then at this point we need to connect it accordingly to the stator phase. Okay, so here is where we apply the star connection. So the function of this neutral wire is to brings the connection back to the three-phase supply. So in other words, it complete the connection right from the phase to the neutral. So once we have turned on the supply, we can simply get the measurement, the reading of these parameters. So that's all for this part.
For this part, I'll be explaining about our three-phase synchronous motor circuit configuration with delta connection. So right here, we have our three-phase synchronous motor here, and this part is our stator, and this is our rotor, and this is our carbon brush. And this is our external drive that which will start up our motor. And this is our meter that we will measure the AC voltage, AC current, the power, and the power factor. Right here, we have our DC voltage supply, and this is our DC meter, which is an analog, and this is our DC voltmeter and DC AC meter, which is in digital. This two meter is called digital multimeter. This is our three-phase supply, and then this is our AC supply. So for the connection here, our stator will be connected to the AC supply and our rotor will be connected to the DC supply. So for our stator, the red phase, yellow phase and blue phase will be directly connected to our meter here, the voltage AC meter, current AC meter, power meter and our power factor meter. And then our three phase here will be connected to our stator here in the form connection of delta. As you can see here, the blue phase is also connected to the yellow phase, the red phase is connected to the yellow phase, and the blue phase here is connected to the red phase. So this is a delta connection. And by the way, delta connection is a three-phase, three-wire system. So meaning there is no neutral connection for our delta connection. Next is our DC part, which is connected to our rotor. So our DC supply here will be connected to our analog multimeter and also our digital multimeter, parallel for our this voltage and series for our current, and then it will be connected to our carbon brush, and our carbon brush will transmit the electrical energy to our rotor. So here will be connected to positive, and this terminal will be connected to our negative. So that is all for the connection for our three-phase synchronous motor for delta connection.
Hi, my name is Zamir Ali bin Shwariman. My metric number is CE190028. So in this presentation where we explain about the wiring connection for stator in delta. So this is the wiring connection for stator, and to make this connection where we refer the circuit that given in the lab. So for red line, where we connect to the volt, and then for the output volt we connected to the Y line, and then for red line where we connect to the point 6 and 7, which is pole 1, and then straight to the point 1 and 12 for pole 2, and then straight connected to the yellow line. And then for the yellow line where we connected to point 10 and 11 for pole 1, and then straight to the 5 and 4 point for pole 2, and then directly connect to the blue line. So and for blue line, where we connect to the current, input current, and the output current straightly connect to point 2 and 3, and then go to the point 9 and 8 for pole 2, and then connect to the common straight to the red line. So that is a delta wiring connection for stator. Okay, next is the graph. So this is a graph that show difference between calculated horsepower versus load torque. So where the blue line is stand for star, while the orange line is stand for a delta. So this is a graph for calculated horsepower versus load torque. So this is for AC current stator, which is red, yellow, and blue versus load torque. So there has 6 line for this graph, where three top line is for delta AC current, which is this is L1, L2, and this is L3, red, blue, and yellow. While the bottom line here is for star AC current. Okay, so and then finally is DC current, which is DC current amateur versus load torque. So there's a two line, which is this blue line is stand for star and orange line is stand for delta. So this is the difference of the DC current and load torque for delta and star. So that's all from me. Thank you.